Space exploration has always been a thrilling endeavor, pushing the boundaries of human ingenuity and our understanding of the cosmos. Yet this quest for knowledge has come at a cost. Our ventures beyond Earth have left a trail of debris in their wake, a growing cloud of defunct satellites, spent rocket stages, and fragments from past collisions. This orbital debris, often traveling at astonishing speeds, poses a significant threat to active satellites and future space missions. Imagine a bolt, no bigger than your thumb, hurtling through space at thousands of miles per hour. This seemingly insignificant object, a remnant of a past mission, now has the potential to cripple or even destroy a multi-million-dollar satellite. The consequences of such an event could be catastrophic, disrupting communication networks, GPS systems, and weather forecasting on Earth. The danger posed by space debris is not merely hypothetical. In 1996, a French satellite was damaged by debris from a French rocket that had exploded a decade earlier. In 2009, a defunct Russian satellite collided with a functioning American satellite, creating thousands of new pieces of debris. These incidents serve as stark reminders of the ever-present danger lurking in Earth's orbit. As we continue to launch more satellites and explore further into space, the problem of space debris will only worsen. The need for effective debris mitigation strategies is more pressing than ever if we are to ensure the sustainability of space exploration for generations to come. We must act now, before this silent threat spirals out of control. In 1978, NASA scientist Donald J. Kessler proposed a chilling scenario. He warned that a chain reaction of collisions in space could create an impenetrable debris field, effectively trapping humanity on Earth. This phenomenon, now known as the Kessler syndrome or Kessler effect, is a grim reminder of the potential consequences of our actions in space. The concept is simple but terrifying. As the density of objects in Earth's orbit increases, so too does the probability of collisions. Each collision in turn creates thousands of new pieces of debris, each capable of triggering further collisions. This runaway chain reaction could transform Earth's orbit into a minefield of debris, making space exploration virtually impossible for centuries to come. The Kessler syndrome is not a sudden event, but a gradual process. As the density of debris increases, the rate of collisions accelerates, leading to an exponential growth in the amount of debris. This runaway effect could eventually create a debris belt so dense that it would render certain orbits unusable. While the Kessler syndrome remains a theoretical possibility, it is a risk we cannot afford to ignore. The consequences of inaction are simply too great. By addressing the issue of space debris now, we can avert this potential disaster and ensure the long-term sustainability of space activities. Facing the growing threat of space debris, space agencies and private companies are exploring various methods to mitigate this orbital hazard. One promising approach is deorbiting, a controlled re-entry process that guides defunct satellites and rocket stages back into Earth's atmosphere. Deorbiting typically involves using the spacecraft's remaining fuel or deploying onboard propulsion systems to slow its velocity. This controlled descent causes the spacecraft to enter the Earth's atmosphere at a specific angle and velocity, ensuring it burns up completely upon re-entry. For larger spacecraft or those in higher orbits, a controlled descent to a remote area like Point Nemo, also known as the Spacecraft Cemetery, is often preferred. However, deorbiting is not without its challenges. Many older satellites were not designed with deorbiting capabilities, making it difficult to remove them from orbit. Additionally, deorbiting requires careful planning and execution to ensure the spacecraft disintegrates completely and doesn't pose a risk to populated areas on Earth. Despite these challenges, deorbiting remains a crucial tool in our efforts to manage space debris. By safely removing defunct spacecraft from orbit, we can reduce the risk of collisions and protect the space environment for future generations. Section 4. Point Nemo, Earth's Spacecraft Cemetery. Thousands of miles from any landmass hidden beneath the waves of the South Pacific Ocean lies Point Nemo. This remote and desolate location, officially known as the Oceanic Pole of Inaccessibility, has earned a unique distinction, Earth's Spacecraft Cemetery. It is here that decommissioned satellites, spent rocket stages, and other spacefaring remnants find their final resting place. Point Nemo's isolation makes it the ideal location for spacecraft disposal. The nearest landmass is over 1,600 miles away, and the region is sparsely populated by marine life due to its unique oceanographic conditions. This remoteness minimizes the risk of debris impacting populated areas or causing significant environmental damage. Since the 1970s, space agencies worldwide have used Point Nemo as a controlled re-entry zone for large spacecraft and debris. The list of residents includes the iconic Mir space station, over 140 Russian resupply vehicles, and even the first space station launched by the United States, Skylab. While the name Spacecraft Cemetery evokes images of intact spacecraft resting on the ocean floor, the reality is far different. The intense heat generated during re-entry causes most spacecraft to disintegrate completely before reaching the surface. What remains are small, fragmented pieces scattered across a vast area of the ocean floor. Section 5. Weighing the environmental impact. The use of Point Nemo as a spacecraft graveyard while offering a practical solution for debris disposal raises important questions about its environmental impact. While the remoteness of the location minimizes the risk to human populations, the long-term effects of depositing space debris in the ocean remain a subject of ongoing research and debate. Some experts argue that the environmental impact of spacecraft debris is negligible compared to other forms of marine pollution, such as plastic waste and chemical runoff. They point to the relatively small amount of debris deposited at Point Nemo and the fact that most of it disintegrates completely upon re-entry. Others express concerns about the potential impact of debris on deep-sea ecosystems. While the ocean floor at Point Nemo is sparsely populated, it is home to unique and fragile life forms that could be affected by the introduction of foreign materials, including metals, plastics, and potentially hazardous substances. More research is needed to fully understand the long-term ecological consequences of using Point Nemo for spacecraft disposal. As we continue to explore and utilize space, it is crucial that we do so responsibly, minimizing our impact on the environment both on Earth and beyond. Section 6. Ensuring a sustainable future for space exploration. As we venture further into the cosmos, the issue of space debris demands our urgent attention. The consequences of inaction are too great to ignore, with the potential to jeopardize not only future space exploration, but also critical infrastructure and technologies we rely upon here on Earth. International cooperation is paramount in addressing this global challenge. Spacefaring nations must work together to develop and implement comprehensive debris mitigation strategies, including improved spacecraft design, active debris removal technologies, and responsible end-of-life procedures. Beyond technological solutions, we need to foster a greater sense of shared responsibility for the space environment. Just as we strive to protect our oceans and atmosphere from pollution, so too must we safeguard the space surrounding our planet. The future of space exploration hinges on our ability to manage the debris we create. By embracing sustainable practices and fostering international collaboration, we can ensure that the cosmos remains accessible for generations to come. The stars beckon, but we must tread carefully and responsibly to ensure our celestial journey continues unimpeded.